In this video, I'll show you how to find shadows when the surface changes, and it's in my book, Ellen's Guide to Casting Shadows, where the Kindle is only $5. The simplest surface change is going from a horizontal to a vertical surface. So here's a vertical pole and a horizontal shadow direction, and when it reaches the wall, it goes vertically up because the wall is vertical and because the pole is vertical. Here we have a horizontal pole, and we established the seats. So extend both of them until you can find the vanishing point on eye level, as if this wall didn't exist. Then, when the shadow hits the wall, it goes vertically up because the wall is vertical and because this imaginary seat is vertical. The shadow vanishing point outside is always on the horizon, but with artificial light, it can be on any surface. So here we have a room with a light source and a floor vanishing point. And we need to draw this magenta wraparound that goes horizontally away from the floor vanishing point. And when it hits an edge, it goes up vertically. And when it hits another edge, it goes across horizontally. And you're basically drawing a large magenta rectangle. The ceiling vanishing point is vertically above the light on this wraparound, and the two wall vanishing points are horizontally away from the light, again on the magenta wraparound. That's the easy way of finding this. A more difficult way is to draw a horizontal plane that goes through the back two wall corners of the wall here, and it goes through the light, and that will give you the two wall vanishing points. The simplest scenario is when the shadows are vertical and horizontal and lie on the wraparound. So we go from the floor vanishing point to the corner of the room, up the wall to the wall vanishing point that's level with the light. And then for this horizontal pole that's attached to the wall with a floating corner in front, we send shadow lines through the part of the pole that's attached to the wall and light rays through its front to get this intersection right here. Now, most of the time, though, the shadows don't follow the wraparound. And so in this case, we have the wall vanishing point going through the base of the pole, creating an oblique shadow, and it ends here at this green dot. Instead of poles, let's use horizontal and vertical rectangles. So here's a vertical rectangle on the floor, so it has to use the floor vanishing point. The shadow lines go through both bases, then it goes up the wall to intersect the light. This is a shelf on the wall, which we'll call a horizontal floating rectangle. You use the wall vanishing point that goes through the back parts attached to the wall, and the light goes through the floating front corners so that you can find this intersection and this intersection. And this is the same thing, except the shadows are more oblique. Let's look at a horizontal rectangle that's attached to the wall or attached to the floor. When it's on the wall, we use the wall vanishing point to go through the back corners, and the light goes through the front corners to give us these two intersections. When the rectangle is attached to a vertical rectangle on the floor, we use the floor vanishing point to go through the base of this structure to the wall and up. Now this time there are four floating corners. So corners 1 and 2 have light rays that go to these intersections on the wall, while the front corners 3 and 4 go to intersections that are on the structure itself. Here is the same scenario, and we found the wall vanishing point on the wraparound level with the light, and it causes the shadow for the pole on the wall. Now, if you take this whole thing and rotate it clockwise 90 degrees, you'll get a vertical pole on the ground with the light overhead. And that makes sense. This wall is perpendicular to the ground. So if you rotate it clockwise 90 degrees, you'll get what we see on the ground. In this room, I found the usual vanishing point, but there's a new one here, the back wall vanishing point, and that's found by going vertically up from the light to the ceiling vanishing point, then across following the perspective of the room, and then down until it's level with the light. And this back wall vanishing point is useful for shadows for this shelf that's attached to the wall. But once the shadow reaches the ceiling, then you use the ceiling vanishing point. Now, how do you get the shadow on this shelf? You draw a line from the shelf to the vertical reference line that contains the light and the floor vanishing point. And you can use this shelf vanishing point for any objects on this shelf. To find a vanishing point on the vertical reference line that we can use for the top of this box, start with the floor vanishing point and draw a horizontal line until it reaches a corner of the box, then go vertically up and back and extend it until it reaches the vertical reference line. So that's the new vanishing point that can be used for any shadow on top of this box, like this purple one. This is a little more complicated. We have a pole in front of a box and start with the floor vanishing point. When the shadow line hits the box, it goes vertically up and continues in the same direction until it hits the light. You can also find this by going underneath the box to the end, going up at one edge and then back, and where it intersects the light is the end of the shadow. Now you can follow this line back to the vertical reference line and get a vanishing point for the shelf, which you can then use for this vertical rectangle to find its shadow right here. The link to my book is in the comments section below, and please remember to subscribe.